Today let us talk about confidence limits for mean. Confidence limits for success. Confidence limits for mean means it will give you what can be the mean value in a range, how mean can vary in a range. Similarly, how the probability of success can vary in an interval. That is what we mean by confidence limits or confidence intervals. Now, confidence limits for mean is given by the formula x bar plus or minus zc into standard deviation by root n. What is x bar? X bar is mean. Please note the point. This is the formula for confidence limits for mean. Therefore, this x bar has come. You know, at 5% level, the critical value for z is 1.96. So, therefore, if they are asking what is confidence limits for mean at 5% level, you are substituting x bar plus or minus, what is zc at 5% level? 1.96 into standard deviation by root n. Similarly, for 1% level, if they have asked, if they are asking, you are substituting zc is equal to 2.58. Now, confidence limits for probability of success is given by p plus or minus zc into square root of pq by n. This is the formula. P plus or minus zc into square root of pq by n. Let us take an example. The example goes like this. In a sample, 900 days was taken in a town. 100 days were found to be very hot. Find the probable limits of hot weather at 1% level. Probable limits of hot weather at 1% level. Now what is given? 900 days were chosen. Out of that 900 days, 100 were appeared to be hot. So therefore, probability of 100 hot days is probability of success. What is success? Getting hot days is success. So what is P? P is equal to 100 days are hot out of 900. So P is equal to 100 by 900. So 2 zeros cancels. P is equal to 1 by 9. Therefore Q is equal to 8 by 9. Let us substitute in the formula for this is the formula. Why? This we are getting P. Therefore we have to use this formula. P plus or minus ZC into square root of PQ by N. What is P? P is 1 by 9. Substitute plus or minus ZC. At 1% level it is asked. At 1% level ZC value is 2.58. So therefore you are substituting ZC is equal to 2.58. P value is 1 by 9 plus or minus ZC. At what percent level? 1% level. So therefore ZC value is at 1% level it is 2.58. Substitute 2.58 into square root of P into Q by N. P you know it, P you know it, Q you know it, divided by N. N means sample size. How much? What is the sample size? 900. So put N is equal to 900. So then you will get two values. One is 0.084, another one is 0.138. That means the probability of hot days can vary in the range 0.084 to 0.138. Now let us go for the next example. In Delhi, sample of 225 boys' weight was taken, and the mean weight of those 225 boys when measured, it was found to be 67 pounds. Standard deviation is 12 pounds. Standard deviation is 12 pounds. Mean weight is 67 pounds. What we can say about, or what we can infer about the mean weight of boys of population of Delhi. Now solution. They want to interpret something about what is the population, what is the mean weight of boys of Delhi. So therefore they are taking a sample of 225 boys. They have measured the weight. When they take the average is found to be 67 pounds with a standard deviation of 12 pounds. Now, suppose this is mean, this is regarding mean weight. So therefore, for confidence limits, the formula is that mean x bar. Suppose if it is probability of success, then I would have taken P instead of x bar. But here mean weight, so therefore x bar plus or minus ZC. ZC means 1 point at 5% level, 1.96. ZC is equal to 1.96 into standard deviation by root n. So when you substitute that x bar, you know what is x bar? 67 plus or minus 1.96 into standard deviation, it is given to be 12. You are writing 12 root n What is the sample you have taken? 225, root of 225. When you find that plus or minus is there, therefore you will get two values. One value is 65.432, another value is 68.568. So what is the conclusion? ZC is 1.96 at 5% level. So therefore, with 5% level means 95% confidence. With 95% confidence, we can say that the mean weight of Delhi boys varies in an interval 65.43 to 68.568. This is what we mean by the confidence interval for mean weight.